In this class, we are going to prove triangle inequality for inner product spaces. So let us see the statement first. We are having the inner product space, we are calling it as V. Now for any two elements xy belonging to V, we are having norm of x plus y is actually less equal norm of x plus norm of y. Now in order to prove this, we will need some prerequisites that we will recall. Firstly, we should know what is norm of x. So norm of x is actually nothing but inner product of x with x raised to half. Secondly, we should know that finding inner product of two numbers is nothing but what? After finding the value of inner product of two numbers, we actually get what? A real number. Remember, the codomain of the function is a real number. So inner product of any two numbers is nothing but a real number. Next, we will need the statement of Cauchy-Squarz inequality. It says that mod of inner product of x with y is less equal norm x multiplied by norm y as mentioned here. And lastly, a is always less equal a for any real number a. What does it mean? Let us say you are having a number a. Now let us find the relation between a and mod a. There will be three cases. Let us say one real number is 0, let us say real number is negative, and let us say real number is positive. Now what will be mod of a in all the cases? Mod of 0 is 0, mod of minus half, half, right? And mod of 3 will be 3. In all the cases you can see that this mod a is greater equal to a, and that is exactly what I have written here. So all this will be essential in order to prove our triangle inequality. Now we are going to use one trick in order to prove this. The trick is, instead of proving this, we are going to prove this. Norm of x plus y whole square is less equal norm x plus norm y whole square. Later on, we will simply take positive square roots on both sides and we will ultimately get the result. So let us begin. So I will start with norm of x plus y square. So I will say consider norm of x plus y whole square. But what is norm x? Norm x is inner product of x with x raised to half, right? So if we square it on both sides, what we will get? Norm of x square is actually inner product of x with x. Thus, by using this property here, this will be equal to inner product of x plus y with x plus y. Now, by using properties of inner product, this can be written as, so first of all we will fix the first coordinate and we will distribute the second one. So this can be written as x plus y with x plus inner product of x plus y with y. Now naturally the second coordinate is fixed here. Now we are going to distribute the first coordinate. So this is equal to inner product of x with x plus inner product of y with x plus inner product of x with y and plus inner product of y with y, but which is further equal to inner product of x with x is actually nothing but norm x square. So this is equal to norm x square plus, according to the properties of inner product, this inner product of y with x is same as inner product of x with y. So this will be plus norm of y square, but this is further equal to norm of x whole square plus twice inner product of x with y plus norm of y whole square. Now the question is how to move ahead. Now as I told you earlier, inner product of two numbers is nothing but a real number, right? Let us call it as a right now. But what do we know? A is always less equal what? Mod a. So by using this, what we can say? This will be actually less equal norm x whole square plus twice. Remember, this is a real number a for us. So this is actually mod of inner product of xy, right? That's why we have written less equal here, plus norm of y whole square. What is the reason? Since a is less equal mod a for any real number a. But recall what is Cauchy's quasi inequality. This will be further less equal what? Norm of x whole square plus twice mod of inner product of x with y is less equal what? Norm of x multiplied by norm of y, see here, plus norm of y whole square. Now by using simple rule of expansion of a plus b whole square, this is exactly same as norm of x plus norm of y whole square. But remember, what was our LHS? Therefore, norm of x plus y whole square is actually less equal norm of x plus norm of y whole square. Now simply take positive square roots on both sides. So I will say by taking positive square roots on both sides. So what we will get? Norm of x plus y is actually less equal norm of x plus norm of y, and that is exactly what we wanted to prove.